So we're very happy today to have Dr. Elashoff, a professor of medicine, biostatistics, and computational medicine at UCLA, who is also the director of the Department of Medicine Statistics Core, talk to us about various issues relevant to RICMAR scholars and others. He's also a leader of the Biostatistics, Epidemiology, and Research Design program for the UCLA CTSI, and I think most people know of him. He gave a great presentation last week at the Martin Shapiro Annual Symposium, and he's talked about how much the program has grown over his leadership, and we're really looking forward to his talk today. Thank you, Dr. Elashoff.
Thank you. Got my screen. And hopefully everyone can see this. So I'll be talking about data management and data collection strategies. So I'll start out. So I guess my first slide is why talk about data management, data collection strategies, and why am I talking about it? So my background is I'm a biostatistician, and I'll sort of get into sort of the changing philosophy somewhat that I've had over many years of working with researchers and seeing things go well and things go not so well in different research projects. So, so thinking about sort of data management and data collection, sort of start out with sort of some of the basic sort of lessons learned that I've had over time. So the first is that problems in study data collection usually happen at the very beginning of the study. So this is either that sort of insufficient planning or sort of use of sort of databases, data entry systems that are sort of suboptimal and often yield inconsistency. However, it's often the case that small amounts of early effort can prevent large later problems. That with sort of proper focus on the appropriate data collection, that can prevent large problems with sort of messy, inconsistent data that can manifest at the end of a study. And this messy data can create substantial conflict and time and money waste. So I've been part of many research projects where it's often where I come in sort of at the end on the analysis phase, and the study team sort of didn't really put a sufficient focus on their data collection strategies at the beginning, ended up with a lot of problems, and it really created a really bad environment for research because a lot of the objectives that they had initially set out to do couldn't really be done. So a lot of blame and a lot of wasting time and money. But sort of overall, the proper data management collection methods are really crucial for time efficient and reproducible research. So, this talk has sort of come out of in some sense, a philosophy change that I've somewhat experienced over the course of my career. When I was initially in training in biostatistics, the focus on was you have a complex data set and trying to figure out what the best way to analyze the data that's in front of me. And over time, I've realized that the data that does get in front of me doesn't necessarily have to be that way, and that potentially even more fruitful line of thinking is, how do I make sure that I have the right data in front of me to do the analysis? That this second question is often more important than the first. Okay. This is a brief outline of the, and by the way, if anyone has any questions as I go along, please feel free to interrupt me, raise your hand on Zoom, just take yourself off mute and ask a question. I'd be happy to answer any and all questions as I go through my talk. I usually have too many slides to actually make it through anyway, so it's often better if we spend more time on the ones that we can't make it through. Okay, so the basic outline is we'll talk about study data collection design, a little bit about software and databases with a focus on REDCap, and then as time allows, some data management strategies. Okay, so I think that the key questions to ask before you start the process of data collection, sort of what are the goals or purposes of the research? This seems obvious whenever you're embarking on a new research project. It's always basing it on our goals, but it's really crucial to really ensure that the data collection is really supporting the effort to answer the study hypotheses, and I'll go into that as we go along. Sort of what kinds of data are going to be gathered and what methods and procedures will be used to collect, store, and process the information. Sort of crucially, we have to sort of decide what data to gather. Of course, so we need to consider what is the study population, what are the potential subjects that will be providing data, what sources will we be used to gather data, will we be collecting data from participant surveys, will we have study coordinators collecting the data, will we be collecting data from say an institutional EHR, and how much data is actually required. So during the planning stage, this is the time where we want to think through the variables or data points that are actually needed. We then need to create case report forms to capture all the necessary data elements and set up the set of study visits and schedule procedures for that collection. And then I think for many studies to be really successful, it's really important to create a manual of operations to standardize data collection processes, particularly if data will be collected at multiple different locations. Even single site studies can really benefit from a really detailed manual of operations. The manual of operations will be a sort of a detailed protocol of what data will be collected at what times, in what ways, and by whom. And having all, sort of a document that's standardized and really codifies all the different elements is really crucial. Okay, so what variables are necessary for data collection? So we want to collect study endpoints, demographics, clinical characteristics, confounders, and other predictors. We want to ensure that we are within our study database properly keeping track of patients during the study period, enrollment date, study status, completion. We want to make sure that we have sufficient information in our data collection to enable us to fill out reports, including enrollment dates, demographics, and to also collect, if necessary, possible comorbidities, confounders, adverse events, and we want to ensure that we can collect sufficient data to perform the final analysis at the end of the study. And one way I often sort of think about this is that prior to setting out on data collection, it's often very useful to sort of imagine what the your manuscripts for your research project will look like. If you can sort of start envisioning, okay, well, the first manuscript, I'll have a table 1 that will be the demographic characteristics. What demographic characteristics would be expected to be reported in this table? What, say, maybe confounders or other clinical factors would be expected to be included in a report of, and then finally, what outcome variables? And almost going through sort of the mental process of kind of creating the table shells for the paper that will be generated at the end of this research project. If, in some sense, we can have that final manuscript in mind before we start out, we put ourselves into sort of the right headspace to then say, what things are actually crucially important for me to collect and what things may not be. So what are some sort of key failure points in sort of designing the data elements that we're going to be capturing? Obviously, we can collect too little data, and this could be that we fail to collect the key confounders, predictors, prognostic factors. For example, not collecting smoking status if our intent is to do a lung cancer research study, or things like tumor stage, age, or BMI. So whatever the clinical characteristics that are sort of crucially important to not only describe your population, but also potentially be modifiers for the outcome. Of course, collecting too little, not keeping proper track of subject identifiers across multiple different data collection forms that you might have in a study. This sounds incredibly obvious, and it's hard to believe I should be in some sense saying it, but I've been at the end of studies where this has not been done on many occasions, and this kind of mistake is something that can really doom the project to not being able to answer the study questions. Another failure point is collecting too much. This seems like a strange idea that collecting why would collecting too much data be a problem? And the main reason why is that sort of for every data element that you attempt to collect in a research study, that's going to cost you time and money. Okay. So, and a data collection strategy that involves a very large amount of data may make your study almost impossible to do properly. I can give you an example of this. I was the lead statistician on a multi-center research project in transplant, and this was we had received a large grant to really evaluate a number of genomic correlates with infection risk among this population, and the investigators got together at the beginning of the study, and each one of them had a set of things that they thought would be interesting to collect for the study. And that list of items that the investigators decided that they wanted to collect ended up reaching about 500 different items on the research project. We spent a very long time constructing the proper infrastructure to even allow for the collection of that many data elements, and a huge amount of time was spent trying to collect that data. But I can say that even after 6 years of attempt to collect that data, there was vast amounts of missing and incomplete data, because the scope of data collection was just really inconsistent with the amount of effort that the investigators had for data collection. The other element of this that I see very regularly is, even if I haven't been involved in the data collection, I receive a study database for analysis, and that data set may have 200, 300, 400 variables in the data set. And we work through the analysis. My team helps work through the analysis. We may use 20 or 30 or 40 of those different data elements. And the rest of the data that has been sort of painstakingly collected, it's taken the study participants' time, it's taken the study team's time, often just sits in a database not doing anything. So, and I'm going to go through some specific categories of types of data that maybe shouldn't be collected, but this is one sort of failure that and I see time and time again, and really results in just huge amounts of time wasted. So what are some data elements that are particularly things that you should really rethink and not necessarily collect? One is measures with little or no variability. So if essentially every subject is the same on a specific characteristic, we're doing a prostate cancer study, we probably don't need to collect the sex of our participants, for example. But some things like that will just sort of never enter the analysis. On the other end of the spectrum, measures with too much variability, that is maybe something that's sort of different for every different for every person, collecting what high school our study participants went to. It's an extreme example, but there's sort of often then no way to really make use of that data because sort of everyone's different. Next, measures with substantial missing data. So if we have if we just fundamentally can't collect the data elements on a data element on every the majority of subjects, it may not be worth collecting because we're not really going to be able to properly utilize it in an eventual analysis. So measures that can't be obtained consistently. So one of the sort of key hallmarks of good science is that our outcome variables and our predictor variables are consistently collected, and really the same values mean the same thing. But if we can't really do that, if it's not possible to obtain something consistently, it may not be of particular value. Free text. I'll talk more about this, but essentially almost anything that has free text is something you probably want to avoid in your data collection effort, and to ensure in your data collection process you're gonna sort of standardize and not collect any free text data. When working with study participants, making sure that the number of survey questions, the number of items is sort of not too much, because participants will often become fatigued with really long data collection efforts and start to drop off in terms of returning surveys if the questions are too many. So just a little bit more detail. So what are case report forms, or CRFs? CRFs are the methods we use to standardize data collection between individuals and sites, and will be used to tailor data collection for what's needed to answer study questions. And we typically put our items together in forms in such a way that they're tied together by a common theme. So we might have a case report form that is for vitals, so demographics, individual questionnaires, lab values, past medical history. Each one of these would sort of have commonality, and sort of a number of other characteristic groupings of variables that would make sense to keep together in a single form. Okay. So typically the workflow is after we've sort of come up with what data elements that we want to collect, we need to develop a study database to allow for electronic collection of that data. And so, common software environments for building data sets, probably the two most common ones I get at UCLA are Microsoft Excel and say proceed with heavy caution, and REDCap, which is an online data collection tool that that my group uses extensively to provide study databases for research projects. So just starting out with a few sort of general tips that we can use in terms of how to sort of conceptualize the formation of a study database. Is that we always want to sort of structure a data collection sheet as using the observations are rows and variables are the columns. This sort of often will make sense in terms of the data collection, but more importantly, this is how statistical software essentially reads data. And so however we collect our data in a database, it's going to be crucial that we structure it in a form that statistical software is going to have an easy time working with. It's often useful to code discrete variables, say 0, 1 for binary, 0, 1, 2, 3, for example. Crucially using consistent units for continuous measurements. This sounds incredibly obvious, but can often be a failure point in data collection. That when we set up our data collection form, we make it quite, as crystal clear as possible that what the units for the data collection of any measures are going to be. We also want to make sure to break variables with multiple possible values into multiple different variables or columns in a data set. So, for example, if we're collecting blood pressure, we wouldn't want a value to be, say, 120/80. We'd want it to be two entirely separate data elements, say, systolic and diastolic pressure. Again, avoid free text. And crucially, it's important to format data values consistently, such as dates or missing values. So throughout your study database, you want to use the exact same format for dates and the exact same indicators for missing values. Okay. And sort of the last element is to make a data dictionary or a code book for every, particularly if you're going to code any discrete data elements, because ultimately you won't remember. So you never want to have a data collection tool that requires somebody to remember the exact coding. It should be sort of externally documented what the coding structure of any data element should be. Yes. So yeah, in the comment, it's crucial. One of the other, as the comment in the chat from Lawrence, that it's really crucial for sort of knowledge transferal. So when often the person initially creating the database really understands exactly how and why they're collecting the data and what maybe the coding structure is, but when often the person who makes the database will be often not the person who eventually does the analysis, and that knowledge transferring has to be able to happen. And it's if something is well documented in a sort of clear and concise way, it makes it much easier to really sort of teach subsequent people about the data. The other thing is that in some sense, even the person who's really starting the data collection themselves we'll often forget after some data collection efforts can go on for years, and you know, the you from 5 years ago is a different person than the you now, and you will not remember everything that you're doing now. So some of the basic guidelines for data dictionaries. For variables, they should never start with a number. Statistical software will often have a problem with variables that have a number as the first character in the variable name. Ideally, they should be one word if possible, but we in our data dictionary, we also want to, in addition to have a variable name, have complete descriptions of the variables, and it's often useful for them to be the actual question posed in the questionnaire, or the exact framing of a question that a study coordinator may be asking. If it's coming from EHR data, this can also be an indicator of what the specific data element is named in the institutional EHR. We should specify what type of variable, say a numeric variable, a character variable, and then also provide the coding. Okay. So I'm going to give sort of an example of, partly an example of why not to use Microsoft Excel to collect data. This is a fairly typical Excel database that's slightly modified to protect the guilty. But this is I'd say my group has received thousands of data sets that look very similar to this. Okay, and we've coded this with some of the sort of the key errors that typically we've seen occur over and over and over again when data is collected, and particularly when data is collected in Microsoft Excel. So I'll just sort of go through some of the things that we really have to watch out for. One is, so for the sex variable, the person creating this helpfully wanted to sort of include some information about which was male and that one was female and two was male, but this was in some sense created as an additional line of text rather than part of the code book. So it creates an extra line which would artificially create some missing data. This two is the sort of looking at the data procedure. So these dates are sort of well formatted and consistent, except there's been some extraneous text added, sort of explaining that something else different than that happened. So it's often when collecting data into spreadsheet type data collections, it's often sort of natural to want to put potentially sort of comments or qualifiers about specific data elements, because often there might be something unusual about them, and you kind of feel the need to really document. You kind of feel the need to document the sort of the strangeness about this, but you know, but when you try and take something into statistical software, this 7/1909 observation with the comment would turn into a missing data element, and it'd be deleted because statistical software can't read that as a date. So the overall message is to never include extraneous text in with the data collection. If you want to set up your data collection with the ability for the staff to make comments, you know, create an additional comment variable where comments can be included, but don't mix comments and data together. Okay, so now looking for the date of birth, we have an example of the subject number 2 it the study team at the time of data collection wasn't sure what they knew that the participant was born in May of 1963, but they didn't know the date. So they sort of faithfully put a question mark in to indicate that they didn't know that. But the problem is that, and maybe the idea had been that sort of somebody would go back later and fix it, but realistically, that almost never happens. And these kinds of sort of question marks or inconsistencies just sit in the database for years, and at the end, somebody it needs to go back and sort of go through potentially by hand and correct all of these data inconsistencies. And often you don't even, if the data set is sufficiently large, these kind of inconsistencies just you miss them and observationally, and so this would just turn into missing data, and you'd be wondering why you didn't have date of birth on that subject, and maybe you'd go back and figure it out. So when sometimes close enough is good enough in terms of data, particularly since you're often never going to really be able to go back and check individual data elements by hand. So sometimes it's reasonable to just include, say, if you don't know the day, just put the 1st or the 15th or the 30th, just doing so in a very consistent way across all the different missing data. Speaking about missing data, one thing that's quite crucial is to use consistent formatting of your missing data. So in this example, they used UNK for sort of unknown. In general, I will suggest to people that they sort of use one of two strategies: either consistently leaving a field blank if it's missing, or consistently using an NA, like say capital N, capital A. But whatever strategy you use, it's really crucial that it's consistent and that you use the same coding of missing values all the way throughout a data set. Okay. A few other examples. One is this, in this data collection, they used shading of individual rows to indicate that the patient was a Latino patient. Computer software doesn't see shading, doesn't see colors, and it doesn't recognize that as actual data. So if there's an important study characteristic, don't use sort of colors, or it won't. That won't translate to actual data. On the bottom, one thing that one particularly good reason not to use Excel for data collection is that it's very easy to use Excel to do some basic data summaries and analysis. And we always want to really have our data collection, our data sheet, entirely separate from our sort of analytic data file. And using Excel, it sort of often gets mixed and matched. I'm not going to go through, I think, gone through enough on this one, but just as an example of how we would sort of reconstruct this, all of the extraneous lines that were missing are deleted. We have all of the sort of additional text is not included. For missing values, and just using a blank to indicate missing values. If in this case, for one of the fields, they had sort of a star indicating that this was an extreme value. If that is somehow necessary to include, we can include that as a separate notes field. But don't, again, as I said at the beginning, do not try and have sort of two different pieces of information in any data collection field. And in this case, the clinical outcomes for the patients, to just categorize them carefully, and then we can have an additional comments field where we include additional information. And this is what the sort of the data dictionary would kind of look like. We have the variable names. We have a description, as much detail as is needed about what that variable is, what's the measurement characteristics of that variable, and then any coding that is necessary to really understand what, say 1 for female, 2 for male, for example. I'm going to briefly go through this sort of second data sheet to sort of illustrate a couple of additional points. The first one is in the age variable. Now, in this case, they collected the columns were subjects and the rows were variables. This is obviously we want to do it the other way around, but in this case, they mixed the units for their age variable with the actual values. So they had some pediatric patients, and then they also had some adults. And to keep the units there, they put the unit indicator. But in general, again, once we show this to statistical software, this won't treat this as numbers. This will just treat this as a word, and so that's not what we want. The second thing is to be incredibly careful when designing a data collection system, because when we eventually take data into statistical software thinks that, say, for example, the last two genders, the capital MALE and capital M lowercase ALE, statistical software would view these as two entirely different things. Statistical software does not sort of see capitalization as the same thing, and so it would treat these as two entirely different categories. And same with sort of these yes, no, capital Y, lowercase y, it would be sort of different. So in general, is a problem with in any scenario in which people are sort of typing data in. Any inconsistencies in how that data is typed in will propagate and be an inconsistency when we need to do the analysis later. And so we can either set up a data system at the beginning where we have to go through and laboriously by hand correct all of these sort of data inconsistencies, or try and design something from the very beginning where we sort of error-proof our data collection so that these things can't happen. And so the way my group typically collaborates with people to try and error-proof their data collection is to use a tool called REDCap. So what is REDCap? REDCap is a secure web-based data collection tool. It was developed at Vanderbilt in the CTSI program. It supports data entry from case report forms and supports deployment of online surveys. And importantly, no real programming or web development experience is needed to produce a study database. Okay. What does sort of REDCap allow? REDCAP allows databases to be built quickly and easily. It's a secure and web-based, so you can the UCLA instance is the security is managed by the university, and you can have provision access to the database for any number of study team members. You can modify the database during the course of the study as needed. You can also import external data as needed, but you can also export data for analysis, and it will export the data into the format and coding structure for statistical software such as SAS, data, R, SPSS. It also includes audit trails for tracking data access and data manipulation. And importantly, it also has a set of user rights, so different members of the study team can have different permissions. So if you have a multi-site study, you can have the data entry personnel at each site only be able to enter data and edit data that's for their specific site, and they can't see or make any changes to data from other sites. It's also very useful when using a tool like REDCap, because multiple people can be sort of using it at the same time and not interfere with each other. So if you're trying to collect in Excel or any spreadsheet type database, sort of you end up very quickly with version control issues if multiple people want to sort of make edits or put in data at the same time. So at UCLA, there's the primary instance is hosted by the CTRC, and the administrator is Martin Lai. If you want to get started with REDCap, here's his email address. UCLA maintains 2 REDCap servers, and the external REDCap, which supports databases that do not include any PHI, and the external REDCap is accessible from anywhere with an internet connection. There's also an internal REDCap, and this can be used when you have data that needs to contain PHI. And this is only accessible through MADNet or through VPN. And when you're putting together a database, it starts out in development mode, and then you move it to production mode once you start collecting data. And to be in production mode, it has to have an active IRB, and data collection forms cannot be modified directly by the study team. They need to work with Martin Lai to make changes, for the main reason that you do not want to. Some changes may sort of corrupt the overall structure of the database, and Martin helps people make sure that changes won't sort of ruin the data that they already have. Okay. So when you're putting together a REDCap database, it's sort of centered around this online designer, where we identify a case report form that we want to create, and then we incorporate variables. And so you can have variables that are text boxes, or you can have multiple choice variables, say radio buttons for the age. You can have drop-down lists, say what is gender, male, female. This drop-down list and sort of radio buttons seem incredibly simple, but they are 2 of the most important structures that really make it possible to collect consistent data. So we can see that there's sort of these 2 choices, male, female. No one has to type in male or female. We don't get any problems with inconsistent spelling or inconsistent capitalization. This can be very useful for, say, collecting medications. So if you decide that you want to determine whether they're on any one of, say, 10 different medications that you're interested in for a study, you can create a sort of a yes/no box or radio buttons or a drop-down list for the medications. Then you don't have to be concerned that someone is going to sort of spell the medications differently or use a different name for the same medication. This really makes it very quick to enter the data, since people can just sort of point and click. But not only can they do it quickly, but they will also do it consistently. Sort of spelling and those kinds of mistakes won't be present. We can also have calculated fields. So if we want to say put the say we collect height and weight, we can also have a calculated field so that it'll automatically calculate, say, BMI for us. And you can also create sort of skip patterns. So you can ask a question like, so that if you have questions, say, are you a smoker? And they say no, then it can skip all of the additional questions. So there's a question in the chat. So the question was, Pepperdine doesn't have REDCap. My thoughts on Qualtrics. So I don't use Qualtrics as much, but from the sort of small amount of use that we've had, it's sort of fairly useful for surveys, but that's been sort of the limit to how much I've actually used it. I think any data system that really separates the sort of the data, the the database from the data collection, I think, is going to be, a much stronger approach than a sort of any kind of spreadsheet type data collection system. So the challenge with something like Excel is that if you're entering data into an Excel file, or if you're not careful, you might change existing data that's already there. But if we're using a system like REDCap or Qualtrics, where the sort of the data collection and then the database are separated, that sort of will eliminate the many types of errors that are incredibly easy to make with a spreadsheet type data collection form. So this slide just shows that it's very straightforward to sort of add, edit, create new variables. We can just, using sort of point and click, we can say that we want to create a new variable. We can, with a drop down, just choose which variable type. We call it what we want, and then we can sort of add in the choices. So it's a very, very little. There's not really any programming that's needed. It's mostly point and click and click to create new variables and to create how those variables are coded. Let's see. I'm just going to now when it comes time for the actual data collection process, it'll be crucial to decide whether the data will be collected on paper CRFs or electronic CRFs, it's possible to do sort of both. Using REDCap, you can create the forms within REDCap and then print out paper forms corresponding to the REDCap database. But the crucial thing is that whatever format in order to get good data into REDCap, it has to be collected properly. So if data is going to be collected on paper, we want to make sure that the study forms are created in a way that sort of minimize those errors. So for example, again, having, say, checkboxes for, say, male, female, or medications or past medical history, rather than having forms that require somebody to put in free text. Sort of REDCap also makes it very easy to create sort of longitudinal databases. So this is an example of a study that we constructed the database for. In this, there were sort of an enrollment time period, a baseline, and then multiple follow-up time points. REDCap easily allows you to organize all of the forms that you'll be using at each one of the different visits. And we can see that many of these forms are used at sort of the baseline time point and the sort of final post-cycle 6 time point. The red and green indicate whether REDCap also makes it very easy to manage participants, in that you have a sort of this dashboard for each individual participant, and once a particular form for a particular time point has been entered, it changes from red to green, indicating that data is collected. So with a very quick snapshot, we can see what data has been collected on each participant, and also sort of easily identify things that are still yet to be collected for a participant. The user interface for the data entry looks very similar to what I just showed, and it looks like pretty much any online data form that you've used for, say, online shopping or pretty much anything else. And you can also create tooltips. So sort of yellow text here is it's a potentially pop-up tooltip, which can give specific instructions that you might have just written in your MOP, but can also be incorporated into your database to make it as clear as possible to whoever is entering the data what they should be putting in each different field. And while it may seem obvious to say the person who created the database what you want in each different for each different variable, people are very creative at their interpretation, and they if in the absence of detailed instructions, creativity can have the data entry personnel putting in something very different than what was initially intended. So putting in additional instructions in the data collection form is always can always be very useful. Okay. It looks like I have about 5 more minutes, so I'll maybe wrap up with one more slide. So for data management, REDCap has a lot of useful tools. It provides sort of a graphical data view and a descriptive statistics view, so it can generate univariate tables and figures based on the current data set. This is something that I very strongly recommend as really a first step in any data analysis, is sort of graphing data, creating summary statistics, and there's with any data set that you have, if you there are going to be some mistakes inherent in it, and really the first step of any analysis should always be some basic data summaries. If it's a continuous variable, say the minimum, the maximum, the means, making sure you really understand what values are in the data set. The minimum and the maximum are often useful for finding things that are wrong. So I can give you an example. We have involved in a project looking at a cannabis questionnaire for UCLA Health patients, and one of the participants wrote that their age in years was 70 million. Now, obviously, that's a completely ridiculous value, but just by sort of making a bar chart or looking at the basic data summaries, we could immediately see that value is a problem. So even if you do collect your data properly and really consistently, there will still be mistakes because there either some misinterpretation or what have you. So it's always really crucial to then look at your data, no matter how carefully it was collected, to just find the potential errors and fix them before you go to any analysis. I think the worst case scenario often after you finish data collection is just to load up data into statistical software, assume the data is high quality, but then find out later that your analyses are in error because of a mistake that sort of found its way into the data set. Okay, so I have a lot more, but I think we're at time. So I'd be happy to answer any questions that may have come up. And thank you for the comments in the chat. But as a response to Lawrence's comment, training is very important. I can't second that enough. Whenever we've had, particularly with multi-center studies, that whenever we have a new data entry person, it's always crucial to go through the entirety of the sort of onboarding and training process, because you kind of get, as you often get used to a project and sort of forget what it's like to just sort of be the novice. And it's really important to have a consistent training protocol so that new users will sort of really know exactly what to do, and that is very important for consistency. Question?
Yeah, real quick, just an announcement to please go to the chat and click our evaluation to fill out the evaluation after this session. We also have a session immediately after this that I'll put in the chat as well. But David has a question.
Oh, thank you so much. That was really helpful, and it was great to see it, your tips and things. So sometimes when we collect data, some of the variables, even though they're categorical, may be a little bit subjective depending on who the data collector is and things. And so one time I had them ask if I had double abstracted some of the charts or something like that to make sure there's some congruence. How do we run into that? And also, does REDCap have a built-in way to kind of assess congruence in some of the categories?
Yeah, you can design it so that I mean, there's a few different ways to potentially structure it. One, you could structure it as sort of repeating forms, for example, so that multiple people could fill out the same values, and then you could just sort of run a direct compare. But I think yeah. So there would be definitely a number of possible different ways to structure that in REDCap. But and then there would also be, since there are calculated fields, you could also create a calculated field. If you sort of have two different forms, then you can create a calculated field that will sort of cross the two different forms and say were the values equal to each other or not for each of the different. So you could basically create a form which is just sort of full of indicators, calculated indicators that represent whether the forms are equal to each other. So you wouldn't even have to bring the data into statistical software to get an evaluation of consistency between your raters.
Is it okay if I reach out to you afterwards to try
Absolutely.
to?
Absolutely.
That'd be great.
Yeah. So if for anyone on the call, feel free to reach out to my group for help. So our website is our main email is domstat@mednet.ucla.edu. And if you go to our main website, that email address is also from our main website, which is, if you do a web search for UCLA Domstat, DOMSTAT. Our group provides free assistance with REDCap consulting, and we also will have a sort of fee for service to build REDCap databases for research projects. And our group has created approximately 50% of the REDCap databases that currently exist at UCLA. So we have a lot of experience with it.